Hello everyone, once again welcome back to this channel. In this video we are going to cover by parts rule of integration, by parts method of integration. This is the third method of integration. The first one was substitution, the second one was partial fraction. So these two methods have been covered in the previous videos. So this entire video is dedicated to by parts rule of the integration. Guys, this method is also known as product rule of integration. Product rule. In differentiation, we have studied product rule, quotient rule, right? So in integration, this by parts method is known as product rule. Why product rule? Because whenever two functions are given in multiplication, and suppose we have to integrate them, then by parts rule is applied here. According to this method, first function is written as it is, and then we have to integrate second function. First function as it is, then integration of second, then minus, then we have to differentiate the first function. Differentiation of first, and then integration of second, right? Differentiation of first, integration of second, then these two terms will be multiplied together, and the entire expression, will be integrated again with respect to x. So guys, this is the by parts method of integration. According to this method, first of all we have to write the first function as it is, then we have to integrate the second function, then minus, then differentiation of first, integration of second, then these two terms will be multiplied together, and then the entire term will be integrated again with respect to x, right? So guys, as you can see, these two terms are in multiplication, and now we are integrating them by using this formula. So that's why student also say that this is the product rule of integration. Okay, so now the question is, when two functions are given in multiplication, let's say we have to integrate x into ex. There are two functions. X is a polynomial function, algebraic function. This ex is an exponential function, and these two terms are in multiplication, right? So which function will be first function and which one will be considered as second function? क्वेश्चन क्लियर है? कौन सा फंक्शन फर्स्ट होगा, इसमें किसको हम सेकंड मानेंगे? सो गाइज, फॉर दैट वी हैव टू यूज अ रूल I late. According to this rule, I refers inverse function, L stands for logarithmic function, A बोले तो algebraic, T means trigonometric function, and this E represent exponential functions. So guys, we have to follow this order, I late. According to this order, whichever function comes first will be considered first function, and then whatever be the function which comes later will be considered second. Like you can see, this is a algebraic function, algebra. This is exponential. This is algebra. This is exponential, right? So according to this Eilert rule, algebra comes before exponential. Algebra is the first, this exponential is the second, according to this Eilert rule, right? So here in this situation, this algebra will be considered first, and this exponential function will be considered as second function. Now we can apply this by parts rule in this situation. Like according to this rule, the first function will be written as it is. x के साथ कुछ भी नहीं करना, जैसा है उसे यहाँ पे लिख दो भाई, लिख दिया. Then we have to integrate second का integration ex का integration. What is integration of ex? Answer is ex. Then माइनस, ओके फाइन। देन डिफरेंशिएशन ऑफ फर्स्ट, x का डेरिवेटिव क्या होता है, आप कहेंगे सर दिस इज 1। देन इंटीग्रेशन ऑफ सेकंड ex का इंटीग्रेशन इज ex, and then this entire term will be integrated again with respect to x, right? So guys, we have x ex minus 1 into ex, the answer is ex। और अभी भी इसका इंटीग्रेशन करना है, x ex minus and integration of ex is ex plus k, and guys ये है हमारा बाय पार्ट्स रूल, दिस इज बाय पार्ट्स रूल, ओके ओके सर। Okay, so guys, let's take another example. Let's say we have to integrate x square into log x. Now you can see this is algebraic function, this is logarithmic function. Okay, so according to Euler's rule, we have to follow this order. Okay, so algebra and log comes before algebra. So if we follow this rule, this log will be treated first, and this x square will be considered as second function, right? So guys, now we are going to use this by parts rule in this situation. So according to by parts method, the first function, it means log, will be written as it is. Then we have to integrate second, integration of x square. Integration of x square is x cube upon 3 minus, then differentiation of log x, this is 1 by x, and then integration of second, x square का integration is x cube by 3, and then this entire term will be integrated again with respect to x. Now this will remain same, log x, x cube by 3. Now you can see this 3 is a constant term, उससे इंटीग्रेशन के बाहर हम ले आएंगे. Now x cube by x will be x square, and then this is x cube by 3 into log x minus, and the integration of x square, this is x cube upon 3 plus k. So guys, this is the answer. Okay, let's take another example. Suppose we have to integrate x square into sin x, okay. So now this is algebra, this is trigonometry. According to Euler's rule के according algebra और trigonometry, algebra trigonometry से पहले है, right? algebra पहले है, trigonometry बाद में है. So जो पहले है will be first, जो बाद में है वो second होगा. So ये first और ये हमारे लिए बन जाएगा second. By parts rule यहाँ पे अप्लाई कीजिए. So by parts rule के अकॉर्डिंग फर्स्ट फंक्शन को ऐसे ही लिखना है. First will be written as it is, then integration of second, sin का integration, this is minus cos. The integration of sin is minus cos, then minus, and differentiation of first, the differentiation of x square is 2x, and integration of second, the integration of sin is minus cos. Okay, so now this is minus x square cos x, minus and minus will be plus, and now we have 2x into cos x. So guys, again there are still two functions in multiplication. Two functions are still there in multiplication. First one is 2x and the second one is cos x. This 2x is again algebra, this is trigonometry. So again, according to Euler's rule, the algebraic function will be treated as first function, and the trigonometric function will be considered as second function. Okay, so in this question the by parts rule is getting applied twice. This is, we are using this function, this rule second time. Okay, so again we have to use by parts rule on in these two terms. So first function will be written as it is, and then integration of second, integration of cos is sin x, minus differentiation of first, the differentiation of 2x is 2, and integration of second, the integration of cos is sin first, as it is integration of second minus first का derivative integration of second. Okay, fine. So now minus x square cos x plus 2x sin x minus, and 2, the integration of sin is minus cos. So the final answer will be minus x square cos x plus 2x sin x and plus 2 cos x plus k. So guys, this is our answer. Okay, so guys, now let's do another question. Let's say we have to integrate log x. Generally, when students are asked the integration of log, they answer 1 by x. 1 by x is the differentiation of log x. And we are asked the integration of log. We have to answer the integration of log, right? 1 by x is not the integration, okay? Yeah. So guys, till now we have done many questions of integration, right? But in none of them integration of log was asked. In none of them the integration of log was required, right? In this situation, we have to integrate the function log x. This log x cannot be integrated by using substitution or partial fraction. We have to use by parts rule in this situation. But the problem is by parts rule is applied where two functions are given in multiplication. There is only single function log. So this log x will be written as log x into 1. Okay, and according to by parts rule, the first function is either this is written as it is or this is differentiated. But whatever be the second function, the second function is always integrated. The second function is always integrated. So we do not know the integration of log, so we cannot take this function as second function. So this will be considered as first and this one will be considered as second function. Okay. So guys, according to now this by parts rule, first function written as it is, log as it is, then integration of second, integration of 1, this is x, minus differentiation of first, derivative of first, log x square derivative, this is 1 by x, and integration of second 1 ka integration x. Now x say this x cancelled out, we have x log x minus 1 and x log x, integration of x, this is x plus k. And guys, this is the integration of log x. Similarly, we can integrate tan inverse x. In tan inverse x, this is an inverse trigonometric function. There is only one single function. So we can write this tan inverse x as a product of tan inverse and 1. And again, we are taking this tan inverse x as first function and this one as second function. And according to by parts rule, first function is written as it is and second is integrated. Integration of 1 is x minus differentiation of first 1 by 1 plus x square, integration of second, integration of 1, this is x, and then this entire expression will be integrated again. Now we have x tan inverse x minus, in numerator we have x and in denominator we have x plus 1 plus x square. Okay, so now guys, how to integrate this expression? In denominator we have 1 plus x square and in numerator we have x with the power 1. So we can use substitution method in this situation. 1 plus x square can be taken as t, 1 ka differentiation 0, x square ka differentiation 2x, t ka differentiation dt by dx. So this will become x tan inverse x, and denominator we have t, x dx, this will be dt upon 2 x tan inverse x 1 upon 2, and the integration of 1 upon t, this is log t plus k x tan inverse x minus 1 upon 2 log, and the value of t, this is 1 plus x square plus k. Okay, so guys, this is by parts rule. Now let me tell you another formula which is derived from by parts rule. Guys, there is a formula that whenever ex is multiplied with fx plus f dash x, we can directly write its integration, which is ex fx plus k. So now question is, how is this formula derived? So the derivation part is, we have to integrate ex into fx plus f dash x, right? If we open the bracket, this ex will be multiplied with fx plus ex multiplied by f dash x. In this part, we can use by parts rule. This ex and fx, these two terms are in multiplication. I am taking this fx as first and this ex as second function. So guys, according to by parts rule, first function is written as it is, then integration of second. The integration of ex is ex minus derivative of first, this is f dash x, integration of second, this is ex, then integration of the entire function plus, guys, this is the integration of this first wala part, right? But we are not doing anything with this second part. We are just writing this as it is. So you can see this and these two terms are same but in opposite sign. You can see this is in negative term, this has negative sign and this has positive sign. So these two terms will be cancelled out and we will be left with fx into ex plus k. So guys, this is how this formula is derived. So guys, according to this formula, whenever we have ex in multiplication with fx plus f dash x, we can directly write the integration ex fx plus k, right? So let's take some examples. Let's say we have to integrate ex into sin x plus cos x. So you can clearly see this sin x is the function fx and this cos is the differentiation of sine, right? This cos is the differentiation of sine. So we can simply write this as ex fx, fx yani ki sin x plus k. Suppose we have to integrate ex tan inverse x plus 1 by 1 plus x square. So guys, in this situation, this tan inverse x can be taken as fx and this 1 by 1 plus x square is the differentiation of, this is the differentiation of tan inverse x. So the answer will be ex tan inverse x plus k, right? Similarly, let's say we have to integrate ex 1 upon 1 plus x 1 plus x whole square. So guys, the differentiation of 1 by 1 plus x is minus 1 by 1 plus x to the power 2. So this is fx और ये हमारे लिए हो जाएगा f dash x, and again we can directly use this formula. So the final answer will be ex fx plus k. Guys, let's take another example. Suppose we have to integrate e to the power x. In numerator we have 1 plus sin x and in denominator we have 1 plus cos x, right? So now we can write this sin x as 2 sin x by 2 cos x by 2. In denominator we have 1 plus cos x, which can be written as 2 cos square x by 2, right? So now when this 1 is divided by 2 cos square x by 2, this will become sec square x by 2 upon 2, plus when 2 sin cos is divided by 2 cos square, so 2 से 2 cancel, cos से cos cancel, we will have sin in numerator and cos in denominator, which will become 10 x by 2. So now you can see 10 x by 2 अगर fx है तो ये हमारे लिए f dash x हो जाएगा. So the final answer will be ex 10x by 2 plus k. Okay, so बच्चों इस प्रकार से हमने इंटीग्रेशन के तीनों मेथड ओवर कर दिए. ठीक है. So from the next video we will start definite integration. Okay, so I'll see you in the next video. Bye bye, have a great time, take care.